Today we will discuss the natural logarithm, which is the inverse function of our exponential function y equals e to the x. Now over here we can see a graph of y equals e to the x. You can see it's an increasing function, and the limb as x goes to infinity of e to the x is infinity. This direction, the limit as x goes to minus infinity of e to the x is 0. The domain, any x value may be put in, minus infinity to infinity, but only positive numbers come out. Now e to the x is 1 to 1. As you can see, it's an increasing function. It has an inverse, and that inverse we're going to call ln x, which is the natural logarithm of x. Natural log has the same properties that functions and inverses have that we talked about previously. The log of e to the x is x. In other words, f inverse of f of x is x. And in the other direction, the exponential function being f of x, f of f inverse of x is x. These are the two properties that define the relationship between the natural log and the exponential function e to the x. Now let's take a look at natural log x, and what we can see is, like every inverse function, the natural log reverses x and y from the function it's the inverse of, which is e to the x. So you see that 2e squared is on y equals e to the x. E squared 2 is on the log of x. So you put 2 into e to the x, you get e squared. You put e squared into the log, you're back to 2. So the x and y values have flipped, and you can see the net effect of that is that this horizontal asymptote, as x goes to minus infinity, the function value goes to 0, has turned into a vertical asymptote. And as a result, we can see the limb as x goes to 0 plus of the log has to be minus infinity, because that's what you get when you flip x and y here. And the limit as x goes to plus infinity of log x is going to be plus infinity. If we stare carefully at this, we can see the domain of this function is 0, infinity. The range, the values that can come out, are minus infinity to plus infinity, and that's just the reverse of e to the x, and that's the standard property here. The domain of f is going to be the range of f inverse. The range of f is going to be the domain of f inverse. E to the a equals b, which is our 2e squared, is reversed by a, which is 2 is the log of e squared. Okay, so e to the a equals b is exactly the same statement as a equals the log of b. And we compare here, e to the 0 is 1, which means the log of 1 is 0. E to the 1 is e, which means the log of e is 1. Log of 0 does not exist. We can see that here. It isn't in the domain. Okay, so basic ideas here. Log of 1 is 0, log of b is 1, log of 0 does not exist. Now our basic properties again, the log of e to the x is x, and e to the log x is also x. Based on this information, we can derive some properties of log x that are important when we work with this thing. First, let's look at the log of x plus the log of y. Now we don't have any properties for how you handle logs, so we're going to have to use the fact that the log and e to the x are inverse functions. So I'm going to take this expression, log x plus log y, and I'm going to raise e to that power. E to the u is e to the log x plus log y. Now, e to the x has properties. E to the a plus b is e to the a times e to the b, so this becomes e to the log x times e to the log y. Now, note, e to the log x is x, so this is x and that's y. And now, if you look at this expression, e to the u equals xy, we take the log of both sides. U is the log of e to the u, is the log of xy. Now, what's the point of this? U is log xy, but u is also log x plus log y, which gives us our first property. The log of xy is the log of x plus the log of y. Now, second property, u equals r log x. We're going to do the same thing. We don't know how to deal with this involving natural log, but we do have properties of exponents. So we raise e to the u power. E to the u is equal to the e to the r log x. Now, from properties of exponents, that's e to the log x to the r. And note, e to the log x is x. So we get x to the r. E to the u is x to the r. We take the log of that expression. We get the u is the log of e to the u, is the log of x to the r. U is log x to the r. U is r log x. The two of them are equal. And that's property number 2. And this is a very useful property because taking the log means that we can get things that are up in the exponent down out of that. And that's useful for solving equations. Now, we can use 1 and 2 to establish two other properties. The log of 1 over x can be written as the log of x to the minus 1, and according to these rules, that's going to be minus 1 log x, or just minus log x. So we get property 3. The log of 1 over x is minus the log of x. And property 4 comes from the other two. The log of x divided by y can be written as the log of x times 1 over y, and now log of xy is log x plus log y, so we get log x plus log 1 over y, and we just learned that the log of 1 over y is going to be minus log y. So finally, we've got the log x over y is log x minus log y, and that's property number 4. Now, we see the properties listed up here. Something to warn you about. There is no property for the log of x plus y. It cannot be simplified. It is different than the log of xy, which can. Another thing that cannot be simplified, the log of x divided by the log of y cannot be simplified. That's different than the log of x over y. Okay, so let's use our properties to simplify some things. So let's take a look at the log of ab squared over root c. Okay, by property 4, that's going to be log of ab squared minus the log of root c. Now, ab squared is a product of a and b squared. So using this property, that's going to be log of a plus the log of b squared. Square root of c is c to the 1/2. I'm going to write it that way. And now we're going to finish by using the property x, the log of x to the r is r log x. And that means that log b squared becomes 2 log b, and log c to the 1/2 becomes 1/2 log c. So let's do another one. So let's assume here that we know the log of a is 2, the log of b is 3, and the log of c is 5. Let's figure out what this mess is. Okay, so notice there's no property about log divided by log, so we're stuck with that. Okay, but we can simplify both the top and the bottom. Okay, here is the square root of ab squared c to the 4th, and we're going to write that to the 1/2 power. The log of b over c is by property 4, log b minus log c. Now, we can move the exponent out in front using property 2. Okay, and now this is the product of 3 things. So using the fact that the product of things is the sum of the logs, we're going to get log a plus log b squared plus log c to the 4th. And now finally, using our log of x to the r is r log x, we get log a, the b squared became 2 log b, the c to the 4th became 4 log c, and now all you have to do is plug in the numbers. Okay, we know log a is 2, we know log b is 3, so 2 times 3 is 6, and we know log c is 5. 4 times 5 is 20, and you do the algebra, and that works out to be minus 7. Now, the log function is really useful if you're trying to solve equations involving exponents. So, for example, 3 plus 2 to the x is 5. Solve for x. Now, that's hard without the log, but if you take the log of both sides, which is what method 1 is going to be, we can write log 3 times 2 to the x as log 5. And now we can simplify the left-hand side using log xy is log x plus log y. So this becomes log 3 plus log 2 to the x equals log 5. Now log x to the r is r log x. So the 2 to the x becomes x log 2. And this is, now we've gotten the x down from the exponent to a place where we can solve for it. So what we do is we subtract log 3 from both sides. Then we divide through by log 2, and we get x is log 5 minus log 3 over log 2. That's method 1 for solving this. Method 2 is to take this equation, and before we take logs, divide by 3. So we get 2 to the x is 5/3. Now we're going to take the log of both sides. We get the log of 2 to the x is the log of 5/3. And log of 2 to the x as before is x log 2. And now we just divide through by log 2. And we've got x is equal to log 5/3 divided by log 2. Now that might look a little different than the answer we got before, but it's actually the same, since the log of 5/3 is the log of 5 minus the log of 3 using property 4 here. So this is equal to that. Finally, let's take a look at an equation involving e to the x. And now these things are actually somewhat easier because e to the log x is x, and we were not actually going to even have to use this law. So we take the log of both sides. Log of e to the 3x equals log of 4 e to the x minus 2. Okay. The log of e to a power is that power, so that side is just 3x. This is the log of 4 times the log of e to the x minus 2. Same property, log of e to the x is x, so the log of e to the x minus 2 is just going to be x minus 2. And we've now got this equation, which is a linear equation in x. We subtract x from both sides, and we get 2x is the log of 4 minus 2. And that means that x is the log of 4 minus 2 divided by 2, which is a perfectly fine solution. But just to illustrate some properties of logs, 4 is 2 squared, right? So we can write it that way. And now using this property, the log of x to the r is r log x, 2 squared becomes 2 log 2. And now you can see there's a common factor of 2 in the denominator and the numerator. So you factor that out, divide through by 2, and what you end up with is the log of 2 minus 1.